Welcome to the Explainer. I am so incredibly excited to take you through today's topic. Now, if you've been following tech news lately, you've probably heard the term quantum thrown around a lot, right? And, it usually sounds like pure science fiction. These magical supercomputers that are going to instantly solve all of humanity's problems tomorrow. But today, we are pushing right past all of that sci-fi hype. We're going strictly by the data to find out where the very real, immediate commercial value of quantum technology actually lives right now. So get ready to focus in. Here is our roadmap for today. We'll start by defining quantum engineering, followed by a hardware reality check. Then we'll explore quantum-inspired machine learning, look at the platforms leading the charge, and wrap up with why the quantum future is already here. All right, let's dive right into Section 1, defining quantum engineering and the grand promise of quantum tech. So, quantum engineering isn't just, theoretical physics scribbled on a chalkboard. It's a massive, multidisciplinary fusion. It slams together quantum physics, electrical engineering, and computer science. The entire focus here is on the practical control of individual quantum systems. We're talking about utilizing qubits. These are the fundamental units of quantum computing that leverage completely mind-bending physical properties. Properties like superposition, where things can exist in multiple states all at once, and entanglement, where particles literally share information instantly across distances. It's like a giant, incredibly complex puzzle. And mastering those quantum systems, well, that's the key to unlocking three massive goals. We're talking computation models that absolutely dwarf today's supercomputers, hyper-secure communication frameworks, and highly sensitive quantum sensors. This is the grand promise. This is what all the excitement is about. Moving on to part 2, the hardware reality check, the bottleneck of physical quantum computing. Okay, so this brings us to the elephant in the room, right? We talk so much about quantum computing, but where is the actual physical hardware? Like, when do you get a quantum chip in your laptop? Well, the harsh reality is that physical quantum computers in a fully mature, fault-tolerant state just aren't completely ready for prime time yet. On one hand, we have physical quantum processing units, or QPUs. The truth is, they're still scaling up, and more importantly, they are highly sensitive to environmental noise. They're fragile. So to work around this, we use classical simulation. We use high-performance computing clusters. Specifically, we're talking about incredibly powerful classical GPUs like NVIDIA A100 and H100 nodes to simulate quantum circuits, currently up to about 36 or more qubits. Actually, scratch that. Think of it more like a digital wind tunnel. We use these powerful classical software clusters to test algorithms, validate models, and prep workloads in a completely safe environment long before they ever touch physical, noisy QPUs. And because of this, today's quantum AI revolution is actually incredibly software-driven. And that leads us to part 3, quantum-inspired machine learning, the software workaround. Now, this is absolutely my favorite part of this whole explainer, because here comes the massive plot twist. We are just sitting on our hands waiting 10 years for physical hardware to mature. Here's the brilliant workaround. Quantum-inspired algorithms don't actually need quantum computers. They process data on the traditional silicon microchips we already have right now, but they use the mathematical frameworks of quantum mechanics. Things like tensor networks, which can handle just incredibly complex data relationships with remarkable efficiency. We are literally taking the genius math of quantum mechanics and applying it to current technology to solve massive problems today. And the results of this workaround? They are staggering. Get this, 50 to 80%. I want that number to just sink in for a second. This is the massive amount by which we can shrink and compress large language models. The incredibly complex AI models dominating the tech space right now, just by using these quantum-inspired techniques. Let's break down exactly why shrinking an AI model by 80% is such a total game changer. First, this compression retains near 100% accuracy, so you don't lose the intelligence. Second, it dramatically lowers inference costs. It's simply way cheaper to run. Third, it reduces latency, meaning the AI responds faster. And most importantly, it enables complex edge computing. This means you can run powerful AI directly on a local device, like your smartphone or a remote sensor out in the field, completely circumventing the need for a massive, expensive GPU server farm. This is incredible, real-world commercial value happening entirely through software. Okay, part 4, platforms leading the charge, the verified toolmakers making it happen. So if the software is where the immediate action is, who's actually building it? Well, there are 3 major players making massive waves right now: Classiq, Multiverse Computing, and Sandbox AQ. Each of these platforms is carving out a highly specialized, absolutely vital niche in the quantum software landscape. Let's break each of their approaches down, starting with Classiq. Classiq is an enterprise quantum software engineering platform, and their primary goal is just removing friction for developers. They use an AI-powered interface and a high-level modeling language they call QMod. So the really crucial point here is that they automatically synthesize and optimize quantum circuits. A software engineer doesn't have to get bogged down in low-level gate coding anymore, essentially manually wiring the quantum circuits ones and zeros by hand. Classiq handles the whole shebang automatically, allowing these circuits to execute across both classical simulators and real QPUs. Next up is Multiverse Computing, a global leader in quantum and quantum-inspired software. Their flagship is the Singularity platform, which is heavily focused on running optimization and machine learning models, particularly for the finance and energy sectors. And remember that massive 80% AI compression we just talked about? Yep, that's right here. Their advanced compression technology allows large enterprise systems to run highly compact models with fully optimized compute resources right at the edge. And then we have Sandbox AQ, an enterprise software provider focused squarely on the convergence of AI and quantum tech. And this brilliantly illustrates their specific edge. Most AI today is statistical AI. It's grounded simply in text matching and pattern recognition. It just guesses the next best word. Sandbox AQ, on the other hand, is pioneering what they call quantitative AI. Their technology is fundamentally grounded in physics-based models. It's a completely different, way deeper way for machines to actually understand the physical world. Because Sandbox AQ uses those physics-based models, they can deliver large-scale simulations for advanced materials design and crucial biopharma drug discovery applications. But perhaps their most vital service right now is post-quantum cryptography, or PQC. They're providing the solutions needed today to safeguard corporate data against the eventual rise of perfect, mature quantum computers that could otherwise just completely crack our current encryption. Finally, Part 5, the quantum future is now, the ultimate takeaway. Look, if you take absolutely nothing else away from this explainer, please take this. The quantum revolution isn't some pipe dream a decade away. It is already here, and its immediate value lies entirely in software. Through advanced classical simulations, quantum-inspired algorithms, shrinking AI models, and platforms like Classiq, Multiverse, and Sandbox AQ bridging the gap, this paradigm shift is unlocking immense commercial value today, long before the physical hardware is fully perfected. So I'm going to leave you with this final provocative thought to chew on. If the software revolution is already happening right now, and the tools exist today to protect against tomorrow's quantum computing power, is your organization prepared for the post-quantum cryptography era? It's a question every single forward-thinking enterprise needs to be asking themselves right now. Thank you so much for joining me on this explainer. I hope you found this incredibly focused and valuable. Keep learning, and I'll see you next time.